In this type of problem in ALEX, you're given two functions and you're going to be given 6 graphs. You're asked to match these equations or these functions with the graphs. So basically, one of the first things you need to do is look at your equation and determine your asymptotes. So we know there's 2 vertical asymptotes because that's the kind of functions they're going to give us. So the first thing we're going to do is we're going to factor both the numerator and the denominator. And I can take common factor out of 3, and I get 3 times the quantity of x plus 2 in the numerator. And in the denominator, I can factor this. There's not a 1 in front of the x squared, so I can use the shortcut. And I know it's going to be x times x. And I'm looking for 2 numbers that multiply to give me -8, but add to give me a positive 2. So that's going to be a positive 4 and a -2. Okay, so I know here that I'm going to go ahead and have these 2 values in the denominator give me my asymptotes. So this is going to give me, if you just set x minus 2 equal to 0, you get x equals 2. And then you take x plus 4 and set it equal to 0. And you get x equals a -4. This comes from the fact that your denominator cannot equal 0. If either one of these factors are 0, then the denominator is undefined because you cannot divide something by 0. Okay? So, basically we're looking for a function that has asymptotes at x equals 2 and 1 at x equals a -4. So those are our vertical asymptotes. We also want to look and see if we have a horizontal asymptote. As you can see, we've divided our graph into 3 sections. Okay, so when you're looking at the power of each of these, so you're looking at the highest exponential power of the numerator and the highest exponential power of the denominator, and they're different. If the exponential power in the numerator is smaller than the one in the denominator, then you have y equal to 0 for your horizontal asymptote. So you're looking for something that has a little dashed line along here. So you can eliminate some of your possible graphs . We know it can't be graph A, B, but C has the asymptotes, so I'm going to just write down my possibilities. C can't be D. E has a -4 and 2 for my x, and y equals 0, so it could be E. And same with F. Okay, so we've eliminated half of the graphs. So now what we need to do then is to consider what's happening as you're in each of these sections of the graph. Okay, so now usually what's going to happen with these asymptotes is your graphs are going to get closer and closer to these values but never cross. But if you notice on some of these, we could have in our middle section a part of the curve that changes direction like this. Okay, so let's see. What's going to happen here. So what we can do is set up a little chart. I don't have too much room here, so let's see. You're basically looking at what's going on to the left of a -4. So I'm just going to say to the left of -4. They do it a little bit differently in their chart, but this is just going to be how I'm going to do it for ours. Okay, and then from that, basically to the right of -4 to in between -4 and what was it? +2. We're going to look at close to both of these sides. So when we're in between these two values, we're going to look at close to -4, and we're going to look at a number close to a +2 and see what's happening. Okay, and then 2 and to the right. Okay, so let's think about what's happening to our g of x graph as x. Let's think of this. So if you have a number that's smaller than a -4, so let's say like a -5, what's happening? Is it going to be negative or positive? Okay, that's what we want to consider. So if you plug in a -5 into the top part here, you're going to have a -5 plus 2, that would give you a -3. So this is going to give you a negative number times a positive number, so the numerator part would be negative. And then down here in the denominator, we would have, if we plug in a -5 here, -5 minus 2, that gives us a negative for that one. And if we plug in a -5 here, -5 plus 4, it's a negative value. And so basically here we've got 3 negatives, okay, multiplied and divided together. So the 2 negatives in the denominator, right, they multiply to give you a positive. A negative divided by a positive is going to give you a negative. So these values are going to be negative. So basically what we're looking at in our graph here is, remember we have C. Are those values getting smaller? Are they negative? Does this graph have negative y values? No, so it can't be C. What about E? Yes. So we have E and F both have negative y values. Okay. Now what you're going to do is you can consider something closer to a -4, like, but in between -4 and 2. So maybe like a -3. Okay, so what's happening here? We go back up to our function here, and if we put in a -3 plus 2, that still gives us a -1. A negative times a positive is a negative. And then here, down here in the denominator, -3 minus 2, that's going to give us a negative value. And the second value here, if I plug in a -3 plus 4, that's going to give me a positive value. So here, a negative times a positive, that will give you a negative. So you're ending up with a negative divided by a negative, which ends up being a positive. Okay? So that those values close to a -4, they're in the positive y. Your y's are positive. Now, what happens as we're closer to a +2? So let's say like a 1. What's happening? So let's plug in a 1. 1 plus 2 is 3. This gives a positive value here. Here, I'll go ahead and change this so we can kind of see. So if I plug in a 1 here, that gives me a positive value. And then plug in a 1 here. 1 minus 2, that's a negative. And then 1 plus 4, that's a positive. And so I'm going to end up with a positive divided by a negative, so this is negative. So my graph, I'm going to have positives here and negatives on this side. So I have positives here, but this is the one that has the negatives on this side, so it is not E, which leaves us with F. You could continue this process if you needed to, but we've determined that it's got to be graph F. And that's how you do these problems. So let's go ahead and look at our h of x function. I believe it was h of x, if I'm remembering correctly. Yes. Same process, factor. X minus 4, x plus 1, and x minus 3, and x plus 2. Okay, so now when you're looking at these, go ahead and determine what your asymptotes are. So, x minus 3 equals 0, so you get x equals 3. And here, this one, x plus 2 equals 0, so you get x equals a negative 2. Okay, so again, so far what we have here is at negative 2, we have an asymptote, and at positive 3, we have an asymptote. Okay, so now you can see from here, we want to also look at the horizontal asymptote. So we look at our leading coefficients here, and these are the same powers. So we simply look at, well, I said coefficients because we're looking at our leading terms here, and then if they're the same powers, we look at their coefficients. And so the number in front of these are both 1s. So this gives us our other asymptote at y equals 1, which is right along here. Okay, so we're looking at our graphs. We're looking for asymptotes at a negative 2, 3, and for the x asymptotes, and for the y asymptote, or horizontal, vertical here, right? This one is at 1. So it could be graph A. And then we're looking at, could be graph B, has those same asymptotes. We know it's not the C, and we know it's not D because this asymptote is at y equals 3 here. So that's not what we're looking for, and we know it wasn't E or F because those have different asymptotes. So we're looking at either A or B as possibilities here. So then we can start our chart and look at what's happening, to the left of negative 2. Is it going to be positive or negative? And then we can always look at in between a negative 2 and 3. And if needed, we look at what's going on to the right of 3. Now, over here, so we could pick a number like a negative 3. Number that's to the left of negative 2, and see what's going to happen when we plug that in. So a negative 3 minus 4, that's going to be a negative number. And then we plug in a negative 3 in the x plus 1, and that's going to give us a negative value. And then in the denominator here, a negative 3 minus 3, that's going to give us a negative 6, so that would be a negative value. And then a negative 3 plus 2, that's going to give us a negative value. So these two negatives will multiply to give us a positive. These two negatives multiply to give us a positive, and a positive divided by a positive is positive. And so that means that our, well, we've got to be a little careful with that too, even. So we know it's got to be positive for negative 3. But we've got to be careful because it could be coming down here. Negative 3 could be positive, but as it gets closer, would it be getting negative? Okay, so let's look at this a little bit closer. Let's see what's happening close to a negative 2. So let's say a negative 1. So if you plug in a negative 1 into here, this is going to give you a negative, and a negative 1, oops, I better not. Yeah, negative 1 plus 1, that's neutral, right? But that's going to give us a 0 divided by anything is going to be 0. And so, well, I can see that point. It's going to work here. Okay, here's the negative 1, 0. If you don't catch that, you can keep working. So it looks like it's going to be graph A. But you can keep going on here, picking, or you can pick a different value if you wanted to.